talk that we have is by Bala Vignesh. He'll be talking about securing your Kubernetes clusters with eBPF.
Good evening, all. Uh, so this is going to be our last event, so please hold on for just 10 or 20 minutes. I will keep it small and then quick. So we are going to see about securing our Kubernetes cluster with help of eBPF. So before we start, not so useful things, a small thing about who am I. So I'm Bala, so I'm working as an SRE in Zscaler. So definitely I'm not an eBPF specialist, so I'm not going to into an inner workings of eBPF and all. So we will keep it over. Okay. We will keep it in an overview, and I will give a nutshell about eBPF. Okay, so a disclaimer, I'm going to share a small, not kind of a demo, but a static thing. So if you are going to intend to use it in your own desire. It may not work. So, okay, so what is eBPF? So eBPF is nothing that, it is not a new tool at all, it is an extended version of Berkeley packet filter. So with the extension, it is more than just a packet filtering thing. So eBPF is a small kernel tool which can run micro mini programs inside the hooks of kernels. So in the live kernel itself, you can add multiple functionalities like getting the traces of an application, enforcing securities, and then changing the network traffic and all. So a simple analogy would be, consider there is a restaurant and there are two spaces in that restaurant. One is the chef space, another is the waiter space. So each day the waiter will load the the groceries and inventories to the chefs, and later it will be prepared as food by the chef and it will be given back to the waiter in order to serve the customers. So here eBPF is a lightweight camera sort of thing which will scan each and every ingredients which is coming in and also going out. So the good thing is it can stop, if it is a spoiled food is coming into the kitchen, it can stop it there. Also, it can avoid the chef, preparing food for an unwanted customer, sort of. So this is a simple analogy. So moving on, the main use cases of eBPF is multiple, it is varied and it is spread across multiple places. But the important thing is monitoring and observability. So monitoring and observability is it is kind of the main use case of eBPF because it is lightweight. It can provide granular data compared to our general metrics. Example, Node Explorer of Prometheus and all can give metrics, but not that granular as eBPF. Also, okay, next interesting thing is performance profiling and tracing. So this is where APM. So instead of using an enterprise APM tools and writing instrumentation for that particular vendor, you can use eBPF, which doesn't have any instrumentation. This is different from OpenTelemetry, which has auto instrumentation. This does not require any instrumentation at all. So your code space will be much more lesser. Also incident handling. So incident handling is an interesting thing. So you can use eBPF also for incident, for RCA analysis, and then postmortems, everything you can use eBPF because you will get what happened inside the kernel at time of incidents. Also networking and security is what we will focus on this talk. So networking, Facebook built an highly scalable and highly performant load balancer called Katran based on eBPF. Also many CNI providers of Kubernetes uses eBPF. For example, Cilium, Falco, most of the CNIs use eBPF because it is lightweight and portable. And security, we'll delve into it more. Okay, so this is Katran. 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 So after I will give you the links and all, okay? That is built by Facebook. Okay, so the main use case for eBPF inside the Kubernetes is, so I will, performance monitoring. So performance monitoring, as told earlier, it is much more better than Prometheus and all. Also, it is Prometheus compatible also. You can use Grafana and existing Prometheus stack for this. Also, custom metrics and telemetry. So you can, in Keda or any event-driven architecture inside the Kubernetes for auto-scaling purposes, you can build a custom metrics, which is much more granular than normal Prometheus or your own custom tracing metrics. So this is a use case. And security threats. So microservices and distributed application, in a way, it is built on distributed networks, so it is much more, there are much more potential attack points. So we can avoid it we can much more make it secure using BBF. So, okay. So in container technology, there is a fundamental flaw in terms of security. If we consider a flat as an VM, it is, if in apartment building there will be multiple flats, just like a VMs in hypervisor, it is much more secure and it has some hard-coded partitions. It is not easy for a guy to enter a different apartment. But a container is sort of a rooms inside the apartments. There are physical boundaries, but are not that much secure. So we have some fundamental vulnerabilities inside the containers as of. For example, container escapes and lateral movement in containers, a much more common issues. For example, even if a container is compromised, which can be a simple container, not that much useful container, from that container, the attacker may, get the host access or try to access different containers, which is much more potential for the attack. Also, their lateral movement is same thing, like moving from one container to another after attacking it, and privilege escalation. Privilege escalation is the main issue with the container ecosystem itself. Even still, Linux have some privilege escalations once in a while, but it is much more easier to have a privilege escalation attack in containers. So also network vulnerabilities, if a simple container has been compromised, from this on that endpoint, he can does a distributed DDoS attack so that it is easy to bring down the cluster once even a simple container is compromised. And information disclosure, so the thing is, it uses all the containers uses a host file system, right, to store the sensitive data. So which is some of these are not encrypted, or of course it is encrypted at rest, but not on the host file system level. So encryption of secrets are not that much great in container ecosystem. So that is also a huge threat. So what we can do is, so this is a simple demo. This works, but for some technical reasons, I didn't give the whole snippets of it. So any Crossplane users here in the house? Okay. So Crossplane is an open source IAC tool, which is a replacement for Terraform. It runs on top of Kubernetes. So it uses all the Kubernetes API metrics and then does the IAC provisioning. So this is a simple Kubernetes Crossplane deployment thing. So you need, in order to access the AWS provider, you need to provide the AWS credentials to it. So this is how you will, pause the deployment. You will give the secret file to the Crossplane thing. So, okay. So what happens is, Crossplane is secure. It uses a distro-less image. Everything is there. But since there is a fundamental flaw in container technology, we can expose these secrets. So usually, the secret has to be only used by Crossplane pods or the Crossplane ecosystem. But what we can do is, we can easily create a pod which uses all the host namespaces. Which is like host PID. It will use the host network, host file system, and the pod I will create will uses, this will uses the host PID, host IPC, and all the host networking parts, and then it will try to access, it will access the service account which is mounted on the Crossplane pod. So it is kind of, it will reach the file system where the Crossplane stores its secret data. So this will definitely work because it has the host permissions to access all the data from the host mount points. So how we can avoid it? There are multiple tools available for eBBF based on security privileges. For example, there are KubeArmor is there. Also, Falco is there for enforcing security privileges. But Falco and other tools doesn't have an enforcing part. They can alert you if there is some security expenses happen, but you cannot, have an enforcement. You cannot enforce around the guardrails you mentioned. So this is a KubeArmor-based policy where you can mention these things, where there is a select wrap, so you can restrict the service account only by accessing that particular select wraps. So based on that label, only that service account can only access that. Apart from it, this will block all the host privileges. So no one can create a pod with host privileges. So if you have a pod with host privileges, you can access the entire host. So as mentioned earlier in the crossplane, so this is really a critical one, because if this particular pod is getting, a crossplane pod is compromised, the whole Kubernetes system is compromised, the whole AWS resources is compromised. So the attacker will get an entry point with a small leakage, and he can, gather the entire resources of a company. So that's it. So this is how we can block, also stop the, host host namespaces. So okay, thank you. Is there any questions? Okay. Thanks for coming to attend the event.